The main circuit consists of power supplies and voltage regulators, a differential pressure sensor which is fed into instrumentation amplification, which in turn is fed into an analog to digital converter. This serially sends data via SPI to an Atmega 644 microcontroller. This controls a pump and valves by switching relays and also an LCD display. Inside the unit is a 180 watt power supply, an NPK09 24 volt DC vacuum pump, a pneumatics manifold which houses the differential sensor and is pressurized and evacuated by the pump. The airflow around the pneumatics manifold is directed by valves. The main circuit is a prototype constructed on Vera board, housing the main microcontroller, the analog to digital converter, and other components. The front panel of the leak detector houses the pitot and static outputs, a start button, a reset button, and the main power switch. When the leak detector is first powered on, it enters an initialization routine. During this time, if no unit is connected, the required pressure will not be reached. After 30 seconds, the pump will stop and the user will be prompted to connect a unit. Air data computers are used on aircraft and they give the main computer information regarding altitude and airspeed. If they leak, they will give incorrect readings, and this is what the leak detector is designed to test. With an air data computer connected to the leak detector, it can now successfully start its initialization routine. The initialization routine lasts for 10 minutes and is necessary to warm up the differential sensors and the instrumentation amplification circuit. During the initialization routine, the manifold is pressurized and evacuated. The LCD counts down the 10-minute initialization routine so the user knows how long is left before a test can begin. The initialization routine can only be interrupted by the user powering the unit down. Once the initialization routine has finished, the system will vent any pressure and prompt the user to press start to begin a test. Once this routine has been entered, the user can now press reset to go back to the beginning of a test. When the user presses start, the pitot channel is pressurized. A settlement period of 3 minutes is then entered. The microcontroller takes an initial reading of pressure. After 1 minute, a second reading is taken. The difference in pressure determines whether the unit under test is leaking. The result is stored and the unit will then vent. Venting at this point is necessary to ensure the leak detector is back at pressure of the day before it begins evacuating the static channel. The static channel is evacuated to simulate conditions at 50,000 feet. A settlement period of 3 minutes then commences before the microcontroller takes an initial reading of the pressure. After 1 minute, again a second reading is taken. The difference in pressure once again will determine whether the unit under test is leaking or not. Leaks of 0.0, 0.1 or 0.2 of a millibar are displayed. Leaks of over 0.3 of a millibar are classed as a failure. When the reset button is pressed, the leak detector will vent back to atmospheric pressure. When the leak detector determines that it is back at atmospheric pressure, the user will then be able to start a new test. At this point, if a user doesn't connect a unit to the leak detector, or the unit that the user connects has an extremely large leak, the leak detector will not be able to reach its desired pressure and will display leak too large to measure. During the design of the leak detector, external air data test sets have been used to set the leak detector up with precision. 0.1 of a millibar is a very small amount of pressure. A lot of data using air data test sets was collected to ensure the leak detector gave accurate results. During the 1 minute leak detection test, If the unit loses more than 0.3 of a millibar in either the pitot or static channel, the leak detector will inform the user that the air data computer has an unacceptable leak. It also informs the user which channel has failed and by how much.